So again, today we're talking about radicals and rational exponents. You guys are going to learn how to use rational exponents to simplify um, different types of expressions, okay? So go ahead and open up your first flap of simplifying radicals. And inside you'll see some blanks, yes? And you have this image, right? Every single one of these pieces has a name, okay? We know that this is the root, okay? But it's not always called a square root. If there's a number there, okay, like say it was a 3 inside of that radical, like this will be called the cube root. If it was a 4, it would be the fourth root, and so on and so forth. That number, that area is called the index, okay? Hence why there's an I there. It's called the index, okay? The symbol, of course, is the radical. The E, wild guess, it is the exponent. It is in the exponent position. And I went over this the other day, but the A, not the base, technically is the base of the exponent, but it's called the what? The radicand. Yes. Okay, all these pieces, these are all the pieces here. And these play a few roles when we're talking about rational exponents, okay? So, looking at these examples here. Number 1 should be super easy, right? 7. Square root of 49 is indeed 7. Again, this is a square root. If they don't put an imaginary 2 there, that root is automatically indicated as a square root. But the other ones, like number 2, the fourth root of 81, you're asking yourself, what number times itself 4 times gives you 81? It is 3. Yes, the fourth root of 81 is 3. Because if you do 3 times 3 times 3 times 3, that is indeed 81. Unlike with square roots, when you were always looking for groups of 2, with fourth roots, you're looking for groups of 4. That's why 3 is your answer here. I realized I wrote 81 and a whole bunch of 3, so let me fix that. This one down at the bottom, the cube root of 216, you're asking yourself what number times itself 3 times gives you 216? That's hard. We do that times itself 3 times, it gives you a large number. You don't divide by 3. You have to think, what number times itself 3 times is going to give you 216? No calculator. They can't figure it out. Break it down. What numbers multiply to give you 216? How about that? Say again. It's an even number, right? I heard 108 and 2. 108 and 2. Can you break down 108?
9 and 10. 9 and 12.
36 and 3, 9 and 12, they all work. I'm going to use 36 and 3 so that way I can get it a little bit smaller. All right, wait, are you sure 36? Yes. Break down 36. That's 6 and 6. Break down 6. 3 and 2, 3 and 2, so on and so forth, okay? These are, what I just did is called a factor tree. Did y'all ever do this a long time ago in your younger years? This is another way to simplify and break down radicals, okay? Here at the school, we don't teach this way anymore, but this is how you can go about, if anything, helping you figure out this problem. These numbers right here, 2, 3, 2, 3, 3, and 2, all of these are your prime factors of 216. So if I multiply 2 times 2 times 2 times 3 times 3 times 3, I will end up getting 216. And don't you see a group of 3 here and a group of 3 here? For every group, we pull out one number, just like we would do if it was the square root, like how we did 2 days ago or 2 class periods ago. For every group, you pull out 1. So I have 2 and I have 3. What do you do to those two numbers? What's 2 times 3? The cube root of 216 is 6. Yes?
How come when you pull it out, it's not by pairs?
The reason, great question. When you pull it out, it's not by pairs because it is a cube root, not a square root. So like here, back in number 2, we would pull out a group of 4. Square root, we would pull out a group of 2. That's 149, 7 times 7, group of 7, 2 group of 7. Everybody understand that? For the last one, what number times itself 5 times gives you 32? 2. You have to also think about the number itself, okay? If it's a small number and you're trying to figure out what number times itself several times is going to give you that number, it's going to have to be small. None of these are going to be super huge. Questions on this? How this applies to your rational exponents, okay, is that you can go from one form into radical form and vice versa using the fact that the E and the I, your exponent is now going to be a fraction, not a whole number, okay? Your exponent now is a fraction and not a whole number. This can be rewritten as the I root, aka for your index, then your number raised to your exponent. Any? Mm-hmm. Exactly. Okay? These two mean the same thing. These two mean the same thing. Okay? So if it's given to you in this exponential form, you can rewrite it in radical form. The denominator is your index. Your numerator is your exponent. Does everybody see that? So, d to the 5/6 power would be written as the 6th root of d to the 5th power. Your denominator is always your index, and your numerator is always your exponent that stays on the inside with whatever your base is. Okay? How would I write this one? Number 6. 7th root e to the 2nd. For this, we would not be able to solve it any further. You are correct. Because first off, for every single one of these, the numerator is smaller than the denominator. If it was the other way around, we could say, oh, we can pull out a group of 5 or a group of whatever. Just like how we did before. The last one would be what? Cube root m squared. Simple enough, yes? Sure? You can go the other way. If it's given to you in radical form, you can go to exponential form. This will be y to the what power? Careful. 3 over 5. Your index is always your denominator. So that 5th root always goes in the bottom. What about number 9? 4 over 3. Again, the index is always the denominator of that fraction that's in your exponent. And what about 10? 7 over 2. Remember, with no index, that's automatically 2 because it's a square root. Okay? It's a square root. Questions? What about, how would you rewrite that in exponential form? X to the 1 over 6. Yes, there's no exponent written here, but there is something there, an imaginary 1. That's a 1/6. Everybody see that? So without it, it's not an accurate 1. Questions? Okay. Last one, putting it all together. Putting it all together. Rational exponents, you can simplify them because since they're rational exponents, you can rewrite them as a radical and then use the skill from the very first class to simplify them. Okay? So for example, number 11, you have 125 to the 1/3 power. My suggestion to you is to rewrite it in radical form. How would you rewrite this in radical form? The cube root of 125. From there, you can simplify. What's the answer? 5. One number times itself 3 times gives you 125, and the answer is 5. What about number 12? How would you rewrite this in radical form? Let me call on a student. How about Zoe? How would I rewrite this in radical form? Of 16. And this is the first power of 16. Okay? What number times itself 4 times gives you 16? It is 2. That's the answer. Simple enough, yeah? Okay. This one's a tad bit different. In radical form, Taylor, what would it be? Cube root of 27 squared. This one's a tad bit different because it's actually an exponent. Please do not do what's underneath the radical and then try to apply the root. Okay? You're not going to have calculators here. It's a lot easier to do the cube root of 27 and then square your answer. This is the same thing as saying this. This is the same thing as saying this. So you can do the cube root first and then square it versus trying to square 27 and then taking the cube root of that. That's a very large number. Okay? What's the cube root of 27? 3. 3 times 3 times 3 is 27. So then it becomes 3 squared, which is, and your answer would be 9. 27 squared is 729, and then try and take the cube root of that. You have to know that that's 9. I'll try to break it down and then get your roots of 3. Questions? Yes? Yes. Other questions?